In question 3, we're given points on a line, 3, 1, 5, minus 4, and we're asked to find the value of a and b given the function in this form. So there's a couple of ways to do this. We know that b is the y-intercept. We could look at it that way. We can't see it on the diagram, so let's approach it by getting slope, an equation of a line, and let's match that off then. So we have a run here between 3 and 5 of 2, and we have a rise between minus 4 and 1 of 5. You can see the slope here is negative, so m is equal to negative rise over run. And we can use the point 3, 1. So y minus y1 equals m times x minus x1 is the equation of a line you've all learnt off. So y minus 1 is equal to minus 5 over 2 x minus 3. So we're going to get multiplying across by 2 just to keep it consistent to what we always do. 2y minus 2 equals minus 5x plus 15. So 2y equals minus 5x plus 17. And in the format they want, y is equal to minus 5 over 2. We can see the slope again, x plus 17 over 2. So a, our slope in this case, is minus 5 over 2. And b is equal to 17 over 2, 8.5. And if we continued this line along this way, it would cross over at 8.5. Another way to approach this question is we have the point 3, 1. If we sub that into the equation, y is equal to 1, so 1 is equal to 3 for x, so 3a plus b. And if we sub 5 minus 4 in, we'll get another equation in a and b. We'll get minus 4 is equal to 5a plus b. And we can multiply this one by minus 1 to get minus 1 equals minus 3a minus b. Adding the two equations together, we get minus 5 is equal to 2a. So a is equal to minus 5 over 2. And then we can sub a back into, let's just take the top one. 1 is equal to 3a, 3 times minus 5 over 2 plus b. 1 is equal to minus 15 over 2 plus b. Bringing 7.5 to the left, we get 1 plus 7.5, 8.5 is equal to b. In question 4, we're asked to graph these functions. So one is called f of x, so we'll write y is equal to 6x minus 2. And they have restricted the domain between minus 2 and plus 2. So that's 5 points if we include 0 in the middle. So if we just put in minus 2 for x, y is equal to 6 times minus 2 minus 2. Y is equal to minus 14. So that's at the extreme end on the left. We have the point minus 2 minus 14. And at the upper end, if x is equal to plus 2, we get y is equal to 6 times 2 minus 2. Y is equal to 10. So once we get our points, we can see what we need to have on the x and y axis. So on the x axis, we just need from minus 2 to plus 2, always the domain. And then on the y axis, we need to go up to 10 and down to minus 14. So I'm just going to change the scale here. 2, 4. So I've changed the scale on the graph, so from 0 to 1 on the x-axis, and from 1 to 2 is the same distance. Be really careful when you start getting good at these that you have the same scale on x, but then you can have a different scale on y. One box here is 2, and that's how we can minimize the size of these graphs. So the point 210 is approximately here. I'm going to get the point in the middle too. When x is 0, what's y? You can see y is minus 2. This becomes 0. So 0 minus 2 is the middle point and then the end point is minus 2 minus 14. So with a ruler, put the ruler up against the tree, join them together, and you have your linear graph. The next one we're asked for, g of x is equal to 2 minus 4x. And you can see the endpoints here. We'll do them first. Minus 3 when x is equal to minus 3. Y equals 2 minus 4x. Be consistent. So y is equal to 2 minus 4 by minus 3. Y is equal to 2 plus 12, which is 14. So the point minus 3, 14. And then when x is equal to 1 at this end, we're going to have y is equal to 2 minus 4 times 1, or just 2 minus 4. Y is equal to minus 2. The point 1 minus 2. So let's set up our graph to get these 3 points on and get the correct scale. So we'll just get our 0 first. If y is 0, you can see all that's left is 2. If x is 0, all that's left y is 2. And we have our 3 points. So when you have your 3 points, do the correct scale diagram. Now it will be given to you in the junior cert and leaving cert, but get used to drawing them in your copies. So we have minus 3, so we start here and we're up to 14. So approximately here, you can see this is going to have a negative slope. The point is 0, 2, 0 on the x2 and the y is here. And the point 1 minus 2 is actually on where the number 1 is here. So I'll just put a 1 here. And if we connect those 3 lines, or those 3 points, with a ruler, it should enable us to then find where the other points are. So we're going to do it on this graph, and then we'll go back to the other graph. So the points we left out here were minus 2, minus 1, just minus 2 and minus 1 for x. So what does x give us at minus 2 off the graph? So if we draw a line up to the graph, a dotted line to distinguish it, and then we go across, our graph should give us approximately, it looks like it's just about at 10. So let's just double check. If x is minus 2, we're going to get 2 minus 4 by minus 2, which is 2 plus 8, which is 10. So our graph is pretty accurate. Then minus 1, if we do the same, let's find out what it is first. 2 minus 4 by minus 1 is 2 plus 4, which is 6. Let's see, does minus 1 give us 6? So put your ruler up against minus 1, up to your graph. You know the answer in advance, so you're going to kind of squeeze it in to make sure it gets right up to 6. So with these, get the answer first and then make sure it fits the graph. You can just do a bigger dot if you're a tiny bit off. So let's go back and do the other one. We left out minus 1 and 1. So if x is equal to minus 1, what does the graph give us? Minus 1. So now let's find out exactly what it is and we'll make it work. 6 by minus 1 minus 2 equals minus 8. So we need to go across from minus 8 to the graph. And you can see we can do a big dot and it works. And then 1, we go up, we're going to get 6 by 1 minus 2, which is 4. So come across from 4, you can see we're bang on here without using a ruler. So with a ruler, 100% accuracy, starting to read from graphs in this question.